Hello and welcome to Learn Statistics class. In this class, we are going to learn the statistical concept in simple and more easy way. The topic of today's lecture is some standard discrete distribution. In this topic, we are going to discuss hypergeometric distribution. In the previous lecture, we have already discussed mean of hypergeometric distribution and definition of hypergeometric distribution. Now in today's lecture, we will learn variance of hypergeometric distribution. So let us start with variance of hypergeometric distribution. If x follow a hypergeometric distribution with parameter n, m and n, then the variance of hypergeometric distribution is given by definition variance x is equal to expectation x square minus expectation x bracket square. In the previous lecture, we have obtained the value of mean, that is the expectation x. So variance x is equal to expectation x square minus value of variance nm divided by n bracket square. Let me call it as equation number 1 for our further reference. Now we will calculate expected value of x square. So consider expectation of x square. I will write this x square as x into x minus 1 plus x for our convenience. So it is equal to expectation x into x minus 1 plus expectation x, which is equal to expectation x into x minus 1 plus value of expectation x is nm by n. This is equation number 2. Now we will calculate first expected value of x into x minus 1, then we will put value of it in equation 2, and after putting the value in equation 2, we will put equation 2 in equation 1 to obtain the value of variance. So we will calculate first expectation of x into x minus 1, which is equal to summation x minus 1 into p of x. By putting the PMF, we get x minus 1 mcx n minus m c n minus x upon nc n. By taking 1 upon ncn constant outside the summation, we will left with summation x minus 1 mcx n minus m c n minus x. But x into x minus 1 mcx is equal to x minus 1 m factorial upon m minus x factorial into x factorial. This can be written as x minus 1 m minus 1 m minus 2 m minus x plus 1 into m minus x factorial upon m minus x factorial into x minus 1 x minus 2 factorial. I am expanding this m factorial m minus x factorial and x factorial in order to cancel some terms. Then we will see that this m minus x factorial get cancelled with m minus x factorial. Similarly, x into x minus 1 get cancelled with this x into x minus 1. So we are left with which is equal to m minus 1, m minus 2 up to m minus x plus 1 divided by x minus 2 factorial. I will take this one as which is equal to m into m minus 1 multiplied by m minus 2 c x minus 2. Substituting this value in expectation x square, we get expected value of x into x minus 1 is equal to 1 upon NCN summation m minus 1 m minus 2 c x minus 2 multiplied by n minus m c n minus x, which is equal to m minus 1 upon n c n summation m minus 2 c x minus 2 n minus m c n minus x, m minus 1 n c n into, we know that the sum of this multiplication of two combinations is n minus 2 c n minus 2 by the result of combination, and we have already learned it in mathematics. So this is the expected value of x minus 1. We will simplify these two combinations, then we get expected value of x into x minus 1 is equal to m minus 1 into n minus 2 factorial divided by n minus 2 factorial into n minus n. The whole thing is divided by n factorial divided by n minus n factorial into n factorial. This n minus 1 factorial, n minus 1 factorial get cancelled, and which is equal to m minus 1 n minus 2 factorial into n factorial divided by n factorial n minus 2 factorial. Then m minus 1 into this n minus 2 factorial get cancelled from this, and n minus 2 factorial cancel from this. So the remaining is n minus 1 in the numerator and in the denominator n minus 1. This is our expected value of x minus 1. Now I will substitute this value in equation number 2 first, and then we substitute the resulting value in equation number 1 to obtain the value of variance. Hence, expectation x square is equal to m minus 1 n minus 1 divided by capital N minus 1 plus nm by n. This is the equation 2, expected of x square. Now we will substitute this equation 2 in equation 1. Therefore variance x is equal to, I will write it as nm by n plus m minus 1 n minus 1 upon n into n minus 1 minus n square m square by n square. This is our equation 1. So we will take a common of nm by n. The remaining terms are 1 plus m minus 1 n minus 1 by n minus 1 minus nm by n. After taking the LCM, we get it is nm by n is equal to into n into n minus 1 plus n m minus 1 n minus 1 minus n m n minus 1. The whole thing is divided by n into n minus 1, which is equal to nm by n square. I am taking the denominator outside the bracket, n square into n minus 1. By multiplying all the terms inside, we get n square minus n plus n m n minus n into m n plus n minus n m n plus n into m. This n m n get cancelled, and this n plus n minus n cancel. So we are left with variance x is equal to n divided by n square n minus 1 into bracket n square minus n minus n plus n into m, which is equal to this constant is as it is. I will take n common from these two and n small n from these two. We get n into n minus m minus n into n minus m, which is equal to these two constant as it is. I will take n minus m constant, so it is n minus small n. Hence variance x is equal to n into m, n minus m into n minus n divided by n square into n minus 1. This is the variance of a hypergeometric distribution with parameter n, m, n. In this way, in this lecture, we learn what is the variance of hypergeometric distribution and how we obtain the expression for variance of the hypergeometric distribution with the help of mathematical expectation. I hope students understand the derivation of variance. If students like this lecture, click on the like button, share with your friends to learn the statistics in simple and more easy way. Students are requested to subscribe the Learn Statistics channel for the upcoming lectures in the upcoming days. Many more concepts are already discussed on the Learn Statistics channel. If students want to learn all the topics, then click on the I button at the top right corner of the screen, and link of all the playlists are given in the description box. Many more discussions are also remaining to discuss on the Learn Statistics. If a student want to learn a new topic from statistics, then please do write in the comment box. I will make a video on it. Then it is easy to learn that topic in simple and more easy way. Now we will meet in the next lecture with the next topic. Till then we will stop here. Thank you.